What happens when you click on the link or type the website name in the browser and hit enter? Let's walk through the steps end to end, from high level into more details. Just a note, I'll be skipping and omitting certain technicalities and low-level stuff. I'll be mentioning this separately in my notes as we go. Let's review. So we all know that when you open the browser on your computer or on your tablet or a mobile phone, it connects to the internet, and somewhere there is a website, and that website is displayed in the browser. Of course, many processes are happening behind the scenes, a lot of connections and interactions and data transfer happening in milliseconds. This goes without you noticing that. Let's review steps in more detail now. It is obvious for everyone that in order to open the website in your browser, you must be connected to the internet. So it could be wireless, it could be broadband, it could be mobile data. When your laptop is connected to Wi-Fi or broadband, of course you have internet service provider that they have their own infrastructure, cables, wires, switches, routers, more servers. And they are connected to outer networks, which is a combination of wires, switches, routers, repeaters, wireless antenna that transfers signal from one place to another, more servers, more wires, cables, etc., etc., etc. And among all those servers, workstations, computers connected together with cables or without cables, somewhere there exists your website. To note, each and every element of the network has its own IP address. This is unique address which can be used in network connection and network interaction. All these elements together comprise internet. Please don't think of the internet as a cloud that we used in the previous slide. That's a combination of wires, servers, all these devices working together. That's a global network. Computer or browser connects to that website and gets the data and shows that data in the window. So strictly speaking, there is a connection established between the server with the website and the browser. How it works physically, of course, the data, the packets will go through all these network infrastructure. They will travel between your computer or phone or tablet through wireless or broadband, through the internet service provider, through other wires and without wires, all the way till they connect to the server where this site is sitting. And then once data is captured, it will travel all the way back to your computer and will be displayed here. So to reiterate what we have so far, we have computer with the browser. Computer has its own IP address in the network. We have server, let's call it server, which has a website there. Website has resources like pictures, videos, documents, hypertext, scripts, styles, etc. Further, I'll be using just the line connecting between the browser and the server, or to connect different elements in my diagrams. But let's agree that this line represents all that network infrastructure. It could be firewalls, cables, wireless devices, switches, routers. Geographically, a server can be located in Antarctica, whereas you are sitting somewhere else. Doesn't matter. Communication happens in seconds. We'll review further a few tweaks that can increase the speed of communication. But strictly speaking, there is a connection established between the browser and the server, and then the resources that comprise the website are displayed in the browser. We just mentioned that all computers, the internet or in the network, has their unique IP addresses. And technically your browser connects to the server located somewhere in the global network using IP address. Just note that when you enter the site in the browser, you are entering the humanly readable site name or domain name. There is a mechanism that the browser is using to convert the humanly readable domain name into the network IP address. However, before that, the browser will try to get the copy of the site if it's available in the browser cache. Then it will try to look for the network IP address in the local file called hosts. Then it invokes the process which is called DNS resolution. DNS stands for Domain Name System. And it's a multi-step process, involves multiple servers. Again, everything is happening behind the scenes without involvement of us as users. The process takes milliseconds. There is a cascade of so-called DNS servers. At a high level, the browser asks DNS server, what is the IP address of this domain name? If DNS resolver has the record for this domain name, it will give an answer. If it doesn't have a record, it will forward the request to another DNS server, and the same process will repeat. If this server does not have an answer, then it will forward the request to another name server until they reach to the DNS root or authoritative name server. Somewhere in this process, some of these servers will have the record that says example.com human name is located in the network at this address, and the data will be sent back to the DNS servers that invoked the request and eventually will reach the browser. Also to mention, there is DNS cache. Now that our browser knows the network IP address of the site that we entered, it will establish the network connection. Connection is established via the stack of protocols TCP IP, and there is certain interaction done between the browser and the server before website data is transferred. First, there's a TCP handshake. The browser sends sync request, server replies with acknowledgement, and the browser replies with acknowledgement of synchronization. For secure connections, there is extra bit of activity. The browser and the server send hello messages. Then there is exchange of certificates and crypto keys. Connection is secure. After handshake is finished, we are ready to transmit data. So all these steps are required to make sure that there is a secure, stable connection established between the browser as a client and the server. Call it tunnel if you wish. TCP connection is a better term. And then both browser and the server will be using this established TCP connection to transmit data. Data transfer is also following specific protocols or sequence and order of steps and specific commands that both sides understand. HTTP, Hypertext Transfer Protocol. In order to get something from the server, for example the homepage of the site, the browser sends HTTP request. There are multiple HTTP requests. One of them is GET. GET sends the instruction to the server to share the specified resources from the specified folder. The server will process that request, and depending on the processing, if request is correct, it will send HTTP response. If everything is fine, it will send 200 OK. And then we'll send the data according to the request. In this case, we're sending text, hypertext, the pictures, the styles, scripts, etc. If the request sent by the browser contains incorrect resource or non-existing resource, then the server may respond 404 no found or other code. Once the data transfer is complete, the browser is ready to render these resources in the window. Page rendering is also a multi-step process. Again, it's done in milliseconds, not seen by us as users, but there is intense work done by your browser after it received the resources from the web server. Quick review of the steps. So at this point of time, our browser received all the images and the hypertext and JavaScripts and style sheets from the server, and it's trying to build the page, how it is intended to be shown to the viewer. Parsing of the text happening. The browser is building document object model, DOM, tree. It's done in the memory, and the tree consists of the various HTML elements. It processes the external references which are mentioned in the HTML. It could be links to external JavaScript, CSS, images. CSS object model is built. This is the abstraction that is a tree of CSS tags. The browser combines document object model and CSS object model and constructs a render tree. Imagine all the rules how different blocks received by the browser, how they should be displayed to the user. It's all determined by this construct render tree abstraction. Layout or flow, and then paint. Paint is an important step. Speaking of the performance of the websites, there are various metrics which are used to measure how quickly website is loading in the browser, and one of those key metrics is FCP, first contentful paint. So it happened here. After paint, there is asynchronous loading of images and assets depending on how they are specified, and JavaScripts are executed. Let's quickly recap what we reviewed so far. So I'm entering the human domain name in the browser, example.com. I hit enter. At the backend, the browser checked browser cache, did not find the content. The browser tried to resolve this name, found IP address from the DNS servers, connected to that server. As you can see from the network details, our browser sent the request GET to the server, asking for the root path, and the server replied with status code 200, okay. Transferred the content of the home page, the HTTP document. Favicon was not found, so the server replied 404, I don't have this resource with me. And additionally, the server sent few JavaScripts to the point of resolving the humanly readable domain name into IP address. This can be seen using the command line as well. So if you run simple command ns name server lookup and provide the domain name, this is the network IP address shared with my computer by the DNS server, and you can see exactly the same IP address in the communication. A few extra notes that I wanted to add here. Earlier in the video I mentioned that the browser is connecting to the server, and I was a little bit sarcastic, or I made the quote-unquote. This is because in reality, as I know it, the browser may be connected not to the server itself, but to, for example, content delivery network server. The web server or abstraction that is acting as a web server may be located very far away from you geographically. And of course, despite the fact that all communications, all those network interactions happen in milliseconds, those milliseconds pile up, and while the signal goes from your browser through all the routers and switches and under the sea and through the air and reaches the server through all the firewalls and other infrastructure, it may take multiple seconds. There was a solution invented called content delivery networks. So very bluntly speaking, this is the network of servers that are located closer to your geography, and these servers contain the cached version of the site. And when your browser is trying to get content of the website from the server, it may be getting the content from the CDN servers, which are located closer to you, less time to interact, faster page loading. Plus, on top, CDN networks provide certain mechanisms to optimize the speed even further, optimize how the resources are being loaded. There are web application firewalls used for the network security. There are extra bot security measures that are used to protect the actual source server from cyber attacks, from DDoS. So this is not only optimization of loading speed for the browser, but also may be used as an extra layer of security for the web server. In these pictures, I was using this nice server with resources on it. Again, in reality, it may not be just a computer. It may very well be a virtual abstraction somewhere in the cloud, which is a composition of servers and load balancers and databases which act as one entity. And for your browser, this virtual private cloud acts as a server, but inside of it there is a load balancer that can determine whether your connection from your browser can go to this server 1 or server 2 or server 10. Those servers somehow interact with internal database that can contain records, data, images, whatnot. There is a backup. These server count may increase or decrease based on how many clients are connected to this infrastructure, and it may look like this. The very last thing which I wanted to mention here, browser is just one of the programs that can retrieve the content of the websites. Browser is a program. There are other programs such as curl or curl if you prefer, wget or wget, or telnet. Example how that works. Let's go to the terminal and run curl command. And you see that in a couple of milliseconds I got content of the website displayed in the terminal. A little bit more fancy, instead of displaying the HTML received from the server in the output of the terminal, let's save it in the local file. We'll use the flag -o, specify the local file name and the main name. So the content of this website has been downloaded into the local file with this name, and now I can review the content of this file. Let's do it. So to recap everything that we've covered, these are the high-level steps that are happening behind the scenes. DNS resolution. The browser converts the domain name of the website that you entered into a network IP address by querying the domain name system, DNS. The browser receives the network IP address of the server where the website is hosted and establishes the network connection. Then the browser sends HTTP request to the server requesting the web page content. The web server receives that request and processes it and returns the HTTP response, which typically includes the response code, HTML, style sheets, JavaScript, images, videos, other resources. Once the browser receives the data from the server, it parses the data, it parses the HTML file, creates the document object model tree, parses the CSS style sheets, and builds the CSS object model, all done in memory, then renders the page and keeps loading resources asynchronously. So we have reviewed on the high level how the browser is interacting with the server and how connections are being established and what happens behind the scenes. Yes, it has been quite a high level review. We did not touch many aspects related to that. We did not discuss what socket is and how network connection is established when we know the IP address. Briefly touched how the servers are built in reality using the virtual cloud infrastructure and other abstractions and the virtual bubbles, if you wish. But hope as an overview that was helpful, and we'll speak later.